So now we're going to talk about machine-to-machine access. So in the previous section, we talked about Vault doing machine authentication and authorization. We're now going to actually talk a little bit about machine-to-machine access. And this one's a tricky one. So I'm Rosemary Wong. I'm a developer advocate for HashiCorp. And one of the pet peeves that I've had, at least in my career, has been sort of the network policy management perspective. It's really tricky to manage network policy. And if you can do it in a way that at least is communicating identity or the intent of your networking, people get really excited about it. So today I'm going to show you a little bit of Consul, which has a service mesh capability. You can use that service mesh capability to control service-to-service communication, but you can also control sort of the outbound as well as inbound communication if you don't have a mesh. So that's also a really important factor in security. So this time we're going to focus on two main sections of our application. Recall we have this coffee application. It should show us a list of coffees. We should be able to buy the coffees. As a caveat to this, the buying mechanism does not work because I don't want to be collecting any personal data or so. But anyway, so there's two aims we're going to have when we implement Consul. The first is that we want to actually have the product access database. So in the previous section, recall that the product application was crashing because it could not access the database. This was on purpose. Right now, we're actually going to fix that. We're going to allow it to access the database now. The other thing we're going to implement is a second rule that only public can access the product at coffees. So if you are accessing the path/coffees and you are the product application, you can access, or public application, you can access product. So this is what I guess they consider intent, right? This is identity policy management, saying, hey, you can only access this application if you are authorized to do so. So this is authorization by service identity. It's primarily implemented through the service mesh. So there is something called a proxy. In this case, we're using Envoy, and we're actually pushing the requests through Envoy, and Envoy will then communicate with all the other Envoy instances. So this proxy basically helps us control and direct traffic between services. Consul implements configurations to control the proxies. So if, for example, product needs to communicate to the database, I tell Consul product needs to communicate with database. Consul will push those changes to the proxies, and the proxies will be able to communicate. So when we think about doing this, on edge devices, for example, the idea is that maybe you have an application running. You also need, in some regards, this proxy available in order to control the service-to-service communication, whether it be the IoT device phoning, pushing data back to sort of a data source somewhere, or they're communicating with each other. Now, this is very important to know that when you have proxies, you can implement MTLS. So this is, I guess, what you call securing east-west traffic, right? You're able to actually have MTLS between services, although there's a caveat to this in that TLS terminates in the proxy. You don't have TLS between the application and the proxy. So if you're working with application development teams, for example, they no longer have to bundle certificates with their application or write libraries and code to access those certificates. Instead, termination is happening with those proxies. So it's MTLS between the proxies. The other important part of having the proxies in place is that network policy is controlled through layer 4 and layer 7. In Consul, this is called intentions. So you're able to control layer 4 policy between sort of the layer 4 network traffic between each proxy. You can also do this on a layer 7 approach as well, which is where I show the two variants, right? So there's products can communicate to database, which is over TCP. And then public communicates to product over HTTP. So we're going to show layer 4 and layer 7. The setup we're going to go through today in the Consul realm is going to involve a multi-step process. Again, this is all automated. What I'm going to show is in Kubernetes, but the process is very similar for even services without Kubernetes. And I'll show you actually how I registered the database within this topology. So from an architectural standpoint, I'm able to sort of incorporate external services into the mesh as well. So the first step is that the product API registers itself to Consul, says, hi, I'm product. And then the Consul agent reports back to the server and says, I have this new service called product. It will then proceed by saying, okay, I have now discovered products API. This is the identity, and now it's going to match to something else, right? So the identity matches to an IP address. Either a security professional or an operations team, you may not need to know the IP address, right? You, at the end of the day, view the identity and you're able to say, this is the product application. These are all instances of the product application. What about this database though? I mentioned, right, that there is a database involved and I need to control the communication between service product to the service database. And actually you can do something by inserting something called a gateway in Consul. This is, again, a proxy. This is another instance of a proxy, but what it will do is control various forms of traffic inbound and outbound from the mesh itself. So an ingress gateway controls traffic into the mesh, right? So anything going in goes through this proxy and then goes to the other application proxies. Anything going out of the mesh can be controlled by a terminating gateway. So this puts a proxy in place for any outbound communication. And then you can actually do some federation between mesh gateways. And the reason why the federation piece is pretty important is that the federation piece primarily involves connecting two gateways together. So this is important because this gives you TLS across clusters. So it could be Kubernetes, it could be VMs, it could be VMs on-premise, it could be VMs in the cloud. The idea is that having the mesh gateways there offers encryption between those two services, and it looks like it's one single pane of glass. So you're able to control network policy from one place. All right, so in our implementation, what we're actually going to do is use a terminating gateway. We want to control outbound traffic from product to the database. The reason this is important is that we don't want every application accessing the database, right? In your on-premise data center, you might say, I trust any number of applications to access the database, even if they don't have the password or username to log in. Similarly here, in this case, we're saying no one else can access the database except for product. So first, I'm going to register the database as an external service in Consul. Consul has to know that the service exists. And the second thing is I'm going to link the database service to a terminating gateway. So this puts a proxy in front of it, sort of a proxy that will allow it to communicate within the mesh. Now, it doesn't mean that there's, again, TLS between the terminating gateway and the database. I have to set that up myself. It's going to be a different set of certificates compared to anything that's going on in the mesh. So if you have questions about the certificates, please let me know. It is kind of complex because service meshes often have like 7 different kinds of certificates to basically control encryption, to basically encrypt the traffic between services. All right, so remember that my product service is not working. This is actually intentional. What happens is that I have product and I have the database. So remember, I briefly mentioned that anytime you have the service mesh, you kind of have this ability to put some kind of control in front of it, this proxy in front of it to control traffic. I've already made this link. So here I actually link the database service to the database instance. In this case, this is an Amazon RDS PostgreSQL database. It is managed by Amazon, but it is internal. So I cannot access this endpoint from my laptop, for example. Although I will show you that, a hint for later, but I cannot access this, right? So as someone who's debugging or as a development team who's working on this, I won't be able to access this. I do know it exists and the services should be able to access it. But currently, I have a network policy that denies everything, right? And this is one of the circumstances that, do you want to do intentions, right, when you have a service mesh, or do you want to do security groups or policy groups or firewall rules, in your data center or any other environment? And the answer is you still have to do both, right? This doesn't take it away entirely. You have to have the security groups to control any direct machine-to-machine traffic, or you have to register those services or machines as identities within Consul. But you do have to use a combination of both, just to achieve sort of the network policy and just to make sure that communications in general are restricted to machine-to-machine or within your network. So you still have to do it. You get that question quite a bit. So what I'm going to do is now actually enable this to connect. Notice this actually told me that it's not connecting, so I'm going to create an intention. This automatically creates an intention for me. This is a layer, what we call layer on the layer 4 side of things. That's because my database uses TCP, right? So I won't be able to use layer 7 unless my database somehow supports that. But in this case, PostgreSQL, it's done over TCP. Right now, the source is product and the destination is database. This is where the identity part, where the intent comes in. I'm not looking at the IP addresses. I'm not adding the IP addresses to a firewall. Here, I'm actually saying product is allowed to communicate to database. And it's still failing. Oh, well, now it's happy, but it could still be failing. So what I'm going to do is I'm going to go in and check for my product. And we'll see. Let's see if it's Kubernetes probably stopped it because it was crash loop back off. So what I'll do is, just for the sake of expediting this, I'll delete it first and then I'll recreate it. All right, so I've recreated everything. I would dump the MTLS configuration to show you that it's actually MTLS and doing east-west, it is encrypting east-west traffic. The only downside is that it is a big configuration dump that's like this JSON, and it takes a while to parse through the TLS configuration. But as this is coming up, this is going to hopefully pick up the change that I pushed out. So the product, for example, hopefully will now be able to connect to the database. So I'll do that. What you'll actually see in this case is that at first I was unable to connect to it, and then it finally picked up the change rate and is able to connect to it now. And if, for those who are curious what this does, this product API just shows the list of products. There's nothing that is fancy about the coffee application other than it prints out products. So right now it's unable to list products. This is also on purpose. It is broken. I will promise you this is broken. We're actually going to show you later how I as a development team can configure a database securely, right? I mentioned that this database was private, so I can't really access it. So how can I configure a database to actually include the products, right? So there's that, but we'll get to that. In terms of the actual configuration, further configuration within Kubernetes and also the console services, I can also add other intentions as well. So what I'll do is I'll apply, let's say, the public API. I mentioned before that the public API needs sort of the layer 7. It needs to allow layer 7 connection to coffees, for example. And so I can actually configure an intention that is layer 7. So this would include, let's say, appware. Here we go. This would include something like, I would allow the method get, I'll zoom in a little bit further. I'll allow the method get to coffees. So from a security standpoint, you can actually do some really fine-grained control over API, even API endpoint authorization, right? So this is where more granular control over API authorization can be done through specifically the service mesh. Previously, the way I did API authorization before was, you would hopefully have some kind of authorization server that might control this. You could also have some kind of API gateway that controls the endpoints and how services communicate to each other. Other times, from a development team standpoint, you might integrate some kind of authentication or authorization server as part of your code base. And in this case, nothing is in the code. Everything is done through these proxies. By the way, this is also showing some of the intentions as well. And there's also metrics. So even from an audit standpoint, if you're interested in learning whether or not some applications were communicating with another, you could basically audit the traffic between the two. Envoy, for example, is open source and it exports Prometheus metrics. So you could take these metrics and if you wanted to audit these from an events perspective, you could actually track the events through tracing. Tracing is a very difficult subject for a number of application teams, right? So you do want to know whether or not an application is communicated to another one, but you also want to know if there's latency between the two. So it serves an operational as well as security and audit purpose. Within a service mesh, you can add observability to it, where you would be able to have those traces available. So you would know whether or not through the proxies themselves, whether or not one proxy communicated with another. So it also actually would be able to understand whether or not there's unauthorized access or terminated access. This one is, I think, a little bit, service meshes are a little tricky. So with Consul in general and service meshes overall, I think that one thing that has been really different in this space, especially if you think about even IoT, is, what topology do you want to use to stretch your mesh, right? Everybody thinks about adding services to the mesh itself, but some services may not be able to make it into the mesh. So if you have an IoT device that's particularly lightweight and may not be able to use these proxies, you might have to use some other topology or other formulation as well. But if your IoT device is capable of supporting a proxy, right, and it will be able to support that TLS, the termination sort of between service to service between the proxies, then you can implement that there.